Okay. Good morning. Good afternoon, class. Good afternoon, class. Okay. So we are winding up with alkenes, and we want to look at reaction 7, and we say that was reaction of bromine water, or chlorine water with alkenes. Okay. Reaction of bromine water and then chlorine water with alkenes. Of course, here the chlorine will first react with water to give us two acids. So this is chlorine gas plus water, which is liquid, is going to give us two acids, which is HCl aqueous plus HOCl aqueous. So you get hydrochloric acid and then the hypochlorous acid. Or if it is bromine, which is plus water, liquid, is going to give us HBr aqueous plus hydromous acid, HOBr, which is aqueous. So we get those two acids. So in this case here, you get hydrochloric acid, hypochlorous acid, hydrobromic acid, hypobromous acid. Now, these two acids are very unstable, and they're the ones which are going to take part in what? The reaction with the alkenes. So in solutions, it is the hypochlorous acid and then hypobromous acid, which are unstable, which will then react with the alkenes. So you can say in these solutions, hypochlorous acid which is HOCl, or hypobromous acid, which is HOBr acids. It is those acids which add to the double bond, and it's going to give us a product that's got two functional groups. So it's going to give us a compound with the two functional groups, the OH group and then the Cl, or the OH group and then what? Bromide group. Now bond producing a compound with two functional, 2 functional groups, producing a compound with 2 functional groups. So for example, if you look at the first reaction, if it's maybe with hypochlorous acid. So, e.g., if I have CH3, CH, double bond, CH2 plus HOCl is going to give me CH3, CH, Cl, CH2, or H.
Excuse me, teacher, what the last word and the small board?
Which one? This one. Which one?
Teacher, down.
Down here.
Down a corner of the first part.
This
Yes.
one here. Which?
Yes.
Which add is supposed to be? Which add double bond producing a compound with the 2 functional groups. And we are saying that e.g., if we have CH3, CH, double bond, CH2 plus HOCl. We get our product being CH3, CH, CH, Cl, CH2, or H, and this compound is going to be, this compound here is going to be 2.
Excuse me, teacher.
Yes.
That last compound is not well clear.
This one
Yes, that last one.
is CH3, CH, Cl, CH2, or H.
Okay, teacher.
Or H. So it's going to be, who can give us the name of that compound? We can name it as 2 dash, because the chlorine atom is on carbon number 2. OH is on carbon number 1. So if it's carbon number 1, carbon number 2. So it's a 2 chloro dash 2 chloro, or we can say 2 chloro propan dash 1 O. Propan 1 O, or we can say 2 chloro dash 1 dash hydroxy propane. 2 chloro dash 1 hydroxy propane, because it is saturated. Because it is saturated. So mechanism for the reaction. Mechanism for the reaction. We shall have CH3, CH, double bond, CH2, and then we rearrange the hypochlorous acid, which is going to be HO, and then Cl. So the chlorine atom is more electronegative than the OH.
I can't sit down there.
You can't sit down here.
Yes, I can't see.
Can't see.
Can we now see? Now we are there, not so. So it's going to be CH3, CH double bond, CH2. Which are saying that this side, this was more negative than the OH group. So this one tends to be partially negative, partially positive. That means that this one is going to attack the OH group. And then as the double bond breaks, attacking the electrophilic end, then this bond breaks, letting all the electrons onto the fluorine atom. And then it's going to give us our intermediate, which is more stable, which is going to be CH3, CH plus CH2 OH. We get the second recarbonium ion as the major intermediate, which is more stable. And this is a slow step. This one is a slow step. That's a slow step. So this one is the intermediate because what? The second recarbonium ion. We could have got this one here. CH3, CH, OH, CH2 plus. But this one is a primary carbonium ion. It is not what? It is not formed. So it is only this one is what? Formed. Then from there, plus the chlorine ion. Then from there,
Yeah, please wait.
Yes?
Please wait.
Okay, I'll stop
Yeah,
there.
please stop there.
Okay. After getting this one here, then we shall go to the next step, which is the first one or rapid step. So next one you're going to have CH3, CH plus, and then you have our Cl minus, but it's using the only pair of electrons.
Excuse me, teacher.
Yes?
Teacher, which acid is that? Hypo what?
Which one?
Here in this solution, hypo. I don't get the
This
word.
one. This one.
Hypo what?
Hypochlorous.
The or.
Hypochlorous acid. HO.
Acid or.
Cl.
Teacher, I get that
Or
one.
hypo.
The or.
Or hypobromous acid, which is HOCl. It is hypochlorous. Hypobromous. Okay? This one here is hypobromous acid. This one here is hypochlorous acid. So in this case here, this one is hypochlorous. This one here, HOBr, is hypobromous acid. Br. This is hypobromous, hypochlorous. We are saying that these two are very unstable, and they are the ones going to take part what? They're the ones which are going to react with the alkene. And not hydrochloric acid, because we say that what? We have this one, we also have what? HCl. This one does not react. We also have what? HBr. This one does not what? React. So it is this one or this one. This one is obtained when we are reacting with chlorine. This one with bromine. Okay? Now, in our mechanism, so the chloride ion is going to attack in the next step, which is a rapid step. So we have that one, we have got CH2OH. Now this one, if we rearrange this one properly, positively charged. So this one will attack what? The carbon which is positively charged, to give us our final product, which is going to be CH3, CH, Cl, CH2, or H. And this one is first. That is the first. This one is the first step.
Excuse me, teacher.
Yes. Question? Yes.
Excuse
You can ask.
me.
The mechanism.
Teacher, I didn't understand the mechanism.
This one. Okay. Maybe you joined late, but let me repeat. We say that reacting with bromine water, okay? We say that it can be the bromine is going to react with water to give us two acids, hydrochloric acid and then hypobromous acid. This one is very stable. This one is stable. This one is very unstable. And then also chlorine plus water is going to give us hydrochloric acid, which is very stable, plus HOCl, which is very unstable. Now, it is this one here, or this one, which attacks the alkene. That's why I say that you get a compound with two functional groups. So we have got the OH group here. We have the OH group and then the bromide group. Even here we have the H group and then the OH group and then Cl group. We have the halogen hydroxyl group. Halogen hydroxyl group. So if you're reacting, for example, propene is reacting with HOCl, it's going to give us CH3, CH, Cl, CH2OH, and we say that when we are naming this one, this is carbon number 1, this is carbon number 2. So this is 2-chloro, not because it's on carbon number 2. So it is 2-chloro-propan 1O. Or we can say 2-chloro-1-hydroxypropane because it's now saturated. So you can either way, all of them are proper names. And then we say that now the mechanism, which leads us to formation of this one here. We say that The alkene, which is propene, will act, will attack the hypochlorous acid. So the OH, the chlorine is minus negative. Therefore, this end is partially negative. This end is partially positive. So it attacks the electrophilic end because this one is lacking what? Electrons. So the electrons will come here. As it comes here, this bond breaks to give us CH3, CH2, OH plus a positive charge here, and then plus a chloride ion, which is this one here. This is the most stable intermediate because what? It's a secondary carbonyl ion. Then after forming this one here, now the chloride ion comes in and attacks what? The positively charged carbon to give us the final product, which is 2-chloro, 1-hydroxypropane. Okay? So this was just explanation. Now we go to next reaction, which is reaction 8. That is reaction with oxygen. Reaction with oxygen. Reaction with oxygen. Now, the alkenes can react with oxygen to give us what we call epoxy alkenes. So they react with, the oxygen react with alkenes plus alkenes to give us epoxy alkenes. So the epoxy alkenes, for example, can be, if this is R, CH, okay, double bond, CH2, reacting with oxygen is going to give us an epoxy alkane, which is going to be R, for example, CH or CH2O. That is an epoxy alkane. Then the epoxy alkane can then react with water at a temperature of around 160 degrees centigrade to give us a diol. So this one is going to react with water in the presence of at 160 degrees to give us R, CH, OH, CH2, OH. So you can use this reaction here in order to produce what? Diols. So first of all, alkene reacting with oxygen will give us an epoxy alkane. Then the epoxy alkane, which is this one here, which is obtained, can react with water at around 160 degrees centigrade to give us a diol. So you can summarize this one in writing briefly so that we can look at the final reaction. So you can say at a temperature of 180 degrees centigrade and in the presence of finely divided silver as a catalyst. So silver acts as a catalyst. Alkenes react with oxygen to form epoxy alkanes to form epoxy alkanes, e.g. if I have, for example, e.g. we have 2 CH2 double bond, CH2 plus oxygen, temperature in the presence of silver, temperature 180 degrees centigrade is going to give us 2 CH2 or CH2 or which is epoxy. This one is epoxy. Ethane. That is epoxy ethane. And then the epoxy ethane can now readily react with water at 160 degrees centigrade to give us a diol. So the epoxy alkane readily reacts with water at a temperature of about 160 degrees centigrade to form a diol. So we can say, for example, if we have CH2 or plus water temperature 160 degrees centigrade. So this one opens, the ring opens, giving us CH2 OH, which is ethane 1, 2, 4 diol. Ethane 1, 2 diol. Then there's reaction we want to bring in, reaction with osmium 4 oxide. I mean osmium 7 oxide or osmium tetra oxide. Also it gives us what? Diol. Also gives us a diol. We need to exhaust all these reactions so that we simplify our revision. So we look at reaction name. Reaction name A.
Excuse me, teacher.
Yes.
Don't we have a mechanism on this?
No, we don't need it. When the mechanism is required, I've given you. Okay. So there,
Okay, teacher.
there's no need of mechanism. So using osmium, osmium 7 oxide, IE, osmium tetra oxide, which is OS or 4. Now this reaction occurs in presence of an ether. It requires in presence of an ether and aqueous sodium sulfide in order to get what? A diol as well. So reaction occurs in the presence of an ether and sodium sulfide to give us a diol as well. So you can say when an alkene is reacted with osmium 7 oxide dissolved in ether in presence of aqueous solution of sodium sulfide, a diol is formed. A diol is formed. So, for example, if we have, we have an alkene, now bond C, and then we are reacting it with osmium tetroxide in the presence of ether, and then aqueous sodium sulfide. We are going to end up forming C, OH, and then OH, which is a diol. Suppose we had this one here. Suppose we had ethene, Ag. If I had ethene, now bond CH2 reacting with osmium 7 oxide in the presence of ether, and then aqueous sodium sulfide aqueous. The conditions are very necessary. It's going to give us CH2 OH and then OH. All of us know the name of that one now. Ethane 1,2 diol. But we can also have another reaction. We can also have another reaction. We can, instead of using osmium 7 oxide in the presence of ether and then aqueous sodium sulfide, we can also react it with ethanoic acid, alkene, in the presence of ethanoic acid and hydrogen peroxide. Still, you are going to get what? A diol. So supposing the reaction is taking place, it's an alkene, but in the presence of a carboxylic acid, for example, ethanoic acid, and then amid this there is also hydrogen peroxide, which is an oxidizing agent. See, the alkene is going to give us a diol. So you are saying that you are reacting an alkene, for example, C double bond C plus you are reacting it in the presence of carboxylic acid. For example, you can have CH3 COOH, presence of hydrogen peroxide. Still, you are going to end up with COH and then OH. And in this case here, temperatures should be between 80 degrees centigrade to 100 degrees centigrade. Still, you end up with a diol. So when we look at this one and then look at the final reaction, which we shall exhaust later on when you're looking at applied chemistry. So you can say also using ethanoic acid,
Excuse me.
yes,
The chemical symbol of is it OS or O5?
OS,
Osmium.
osmium. Osmium 7 oxide or osmium tetra oxide is OS. It is O, small s, then O, capital O, because what? It's an oxide. So it is osmium oxide. Don't write S as full, like this. This one is wrong. When you're writing the formula of these compounds, make sure you follow the system. We say what? The IUPAC system of nomenclature. So also using ethanoic acid and hydrogen peroxide and hydroxylation. In this case, also using hydroxylation in this case, is brought about by heating an alkene in a mixture of hydrogen peroxide. Of course, hydrogen peroxide is an oxidizing agent. Mixture of hydrogen peroxide and carboxylic acid. And the carboxylic acid at temperatures between 80 degrees centigrade and 100 degrees centigrade. So in that case, we are going to have
Teacher, 80 and what degrees?
80 and 100 degrees Celsius.
Thank you.
Okay. 80 and 100 degrees Celsius. So, if we have the alkene, don't have to write the whole thing now. See, that is our alkene. We are reacting it with hydrogen peroxide in the presence of, for example, ethanoic acid, temperature 80 degrees centigrade to 100 degrees centigrade. We are going to have COH and then OH. Seal and di-O. Seal and di-O.
Excuse me, teacher.
Yes.
The second reaction, I mean, part B, is it hydroxy? Okay, the first, yeah. Part B,
Hydroxylation.
the beginning.
Hydroxylation.
Oh, so there is a D. Okay, thank you. Or it's supposed to be like that.
Hydroxylation. It is hydroxylation. You are adding what? OH. You are adding OH.
Hold the mammoths, please.
The what? Hydroxylation in this case is brought about by heating an alkene in a mixture of hydrogen peroxide and carboxylic acid at temperatures between 80 degrees and 100 degrees centigrade. And this is the reaction summarized. We are trying to explain this because in the previous exam, they were telling the students, complete the following, explain without the use of equations, how this is converted to this reaction. So if they say, how can you react an alkene to a dioxide? No, so a diol. Then you cannot be able to explain. We can either use osmium 7 oxide in the presence of ether and aqueous sodium sulfide. It will give you that one. Or you can say, you can also use hydrogen peroxide heated with a mixture, you heat an alkene with a mixture of hydrogen peroxide and carboxylic acid, at temperatures between 80 and 100 degrees to give you a die ore. But of course, most of us have been used to reactions. This one give this one. If they say, write that one in words and then give the name of the product. Some of us may get problems. So we need to look at all these possible solutions. And then lastly, reaction 10. Reaction 10. That is polymerization reactions. Polymerization reactions. Of course, all of us know what polymerization is. What's the polymerization? Who can explain us what polymerization is? Process of what?
Let me try.
Yes,
Polymerization is a process called monomers come up together to form larger particles called polymers.
Okay, that's very good. And then the two types of polymerization, we have addition and then condensation.
Addition polymerization.
So this one's here in the case of alkenes, since we have got double bonds, in this case, the alkenes undergo addition polymerization. So you can say polymerization is the process of linking or joining together many small molecules called monomers, to give larger molecules of much higher relative formula mass called D. Polymers. Process of linking or joining together many small molecules called monomers to give larger molecules of much higher relative formula mass called polymers. E.g., if I have a CH2 double bond, CH2, and then this one occurs at high pressure, of around 1,500 to 2,000 atmospheres temperature 200 degrees centigrade. Is going to give us CH2 into brackets N. And that's going to be our, if these are ethene molecules, this is now going to be polyethene. So, uses of alkenes. Why do we study them? Uses of alkenes. Uses of alkenes. One, use in manufacture.
I can
Manufacture what?
try.
Yes. Use in manufacture of plastics, such as polyethylene. And polypropylene. Another use is ethene can be converted ethene can be converted to ethanol. Ethene can be converted to ethanol, which is then used as an organic solvent, which is then used as an organic solvent. Not only that one, it can also be used as a starting material for processing other or synthesis of other organic compounds. And starting material for the synthesis of other organic compounds. E.g. polyvinyl chloride, PVC. And also, it can be changed to epoxyethane. Ethene can be converted to epoxyethane, which is used in manufacture of detergents. So ethene can be converted to epoxyethane, which is used in the manufacture of detergents.
Teacher,
Yes.
can this point work? I remember,
Sure.
like in all level, they told us that ethene can be used for ripening fruits.
Yeah. It can also use what? Ripening fruits. Is useful. Yeah. Ripening of fruits. Now question.
Excuse me, teacher.
Question we can now play around.
Excuse me, teacher.
Yes. Yes.
On the second point of uses, the
Yes.
last two words. Starting material, what? I don't know. Okay.
Starting material
So it's okay.
for the use of other organic compounds, e.g., polyvinyl chloride. We know polyvinyl chloride is used what? In the manufacture of what? Things like plastic what? Tanks.
Teacher, teacher,
Yes. Well,
can you please explain how ethene helps in the ripening of fruits? How does it come about?
how does it come about? Of course, it acts as, of course, in the fruits we have got sugars, okay? And when it reacts with the sugars, it will be converting sugars very fast to ethanol and then eventually what? To the sugars. So it acts as a catalyst in that enzyme, which brings about what? The ripening. So it is mainly as a catalyst. Now, how can you convert the following? Complete the following conversion. Complete the following conversion. CH3, CH2OH to give us CH3, CH3OH. Because we have looked at alkenes and different reactions, we can play around with this one here. There is elongation of the carbon chain, and then there is also change the OH group, carbon number 2 of propan 2-ol. So in brief, In brief, as you look at your revision approach, this one can assist you to look at other conversions in future. Approach, we can, for example, convert ethanol to ethene. Using what conditions? Here come sulfuric acid, 180 degrees centigrade. We don't put 170 at 180. Now here we become what? Specific. You put on the one, if it is 170, put 170. If it's 180, put 180. Don't put what? In between. Then after getting the alkene, we can add there what? We can halogen, add there halogen what? Alkane, I mean hydrogen bromide, a halo acid. So next reaction is going to be CH2 double bond CH2 plus HBr is going to give us, this one takes place at room temperature, CH3 CH2 Br. After that, we can convert that one. You can react it with cyanide in presence of ethanol. We want to elongate the carbon chain. So you can have CH3, CH2, Br. We react it with potassium cyanide in the presence of ethanol. We are lengthening the carbon chain, which is going to give us CH3, CH2, Cn. So you have the Cn, cyanide has replaced what? The bromide atom to give us CH3, CH2, Cn. Then we can change this on to carboxylic acid. We can change that one to carboxylic acid using water in the presence of an acid. So we can now change CH3, CH2, Cn we add water in the presence of hydrogen. H plus, that's what? Amino acid. And then you can say warm. We are going to get the carboxylic acid, COOH, propanoic acid. Having got propanoic acid, we can now react with the cyanide chloride, CH3, CH2, COOH with.
Excuse me, teacher.
Yes.
KCN, that KCN, what does it stand for? Like its full name?
Potassium cyanide. Potassium cyanide.
Okay, thank you.
Is carbon attached to nitrogen. This carbon attached to nitrogen. Good one. Cyanide. So in the, after that, this one we are going to remove one OH and we are going to have what? A cyanide chloride form, which is going to have us CH3, CH2, CaO, and then Cl. Then we can now convert this one here to an alcohol. We can convert that one to an alcohol, CH3, CH2, CO, Cl. We react it in the presence of
Teacher. Teacher.
Zinc, yes. And then come,
Teacher Mutuya.
yes.
Teacher.
Which one? Zinc,
Teacher.
yes.
That equation, the one before.
This one. Which equation?
Yes. What is
Yes.
that? The catalyst?
H plus.
No, that the second last one. Not just SOCL something.
H3, CH2,
Mm-hmm.
COOH.
So the one
COO.
under that one.
This one. This is propanoic acid.
Under it.
This one.
This one.
CH3, CH2, CO, Cl.
Yes. What is that on the arrow? What
This
is that
is
on the
propanoid
arrow?
chloride. Propanoid chloride.
And one on the arrow?
This one here. Thionyl chloride. SOCl2.
Yes.
Thionyl chloride. You are now removing what? OH. You are replacing it what? With one what? Chloride atom. Okay? Then from there, we are going to convert this one now what? To an alcohol. Zinc in the presence of what? HCl is going to give us CH3, CH2, CH2O, H. Oh. This is going to be, this is called HCl. This is going to give us CH3, CH2, CH2O, H, which is propan 1, O. Or you can just say 1 dash hydroxide, 1 hydroxide propane. It is 1 dash hydroxide propane. One hydroxide propane. Then,
Teacher,
yes,
and what is that on the second last equation? That's catalyst there. What's its name?
zinc,
No, the upper one.
thionyl chloride.
Pardon?
SO. This is the same as you already have it. Thionyl chloride. You remember when you are dealing with that monohalogenation of alkanes. Okay? We use this compound here, thionyl chloride. Monohalogenation of alkanes. Yes. Okay. So, after getting that one, we can now convert this one what? Again, go backward, an alkene. We can now have CH3, CH2, CH2, OH in the presence of sulfuric acid temperature 180 degrees centigrade is going to give us CH3, CH, double bond, CH, CH2, CH2. Then from there, we can go back to our secondary alcohol, which is going to give us now, final reaction is going to be CH3, CH, double bond, CH2. Remember, we say that you add what? Water in the presence of an acid. And then you warm. You are going to end up with the secondary alcohol, CH, OH, CH3. Now this one here can assist you to what? To move from one homological series to another. You cannot start moving from alkanes. We can move to what? Alkenes. We can move to alcohols, then alkynes. Okay? That's what the purpose of this one here to get what? So that we get used for these conversions. So next time I will be introducing aromatics. So it shall be, since you have dealt with alkynes, I think you will be completing. I'll be starting on
Teacher, is that a
aromatics.
new topic?
That is going to be a new topic now. I hope you are through with alkynes, not so? You are through with alkynes. So you can comfortably start with aromatics. And of course, here